Hello and welcome to my physics classes. My dear students, I hope you all are fine and doing well. One important thing I would like to say, hard labor does pay, but smart study is the key of success, is the key of success and is the key of success. Okay, now let us begin with the topic of the day, that is diffraction due to a single slit and width of central maximum. Chapter 10, Wave Optics. Before coming to the definition of diffraction through a single slit, a very important thing is that we should make feel about diffraction phenomenon. For example, whenever light passes through a very small hole, then what happens? Light behaves like wave, therefore this is the screen. This is the screen. Light doesn't travel in a straight line because it behaves as wave, so it travels in this shadow region also. Light travels in a wave form, so this region is also illuminated. It is due to the deviation from its path from here. The light wave get deviated around the corner of any obstacle, epoch obstacle. Okay, so whenever it passes through the corner of the hole, it bends across the surface of the corner. This is the phenomenon of diffraction. Means diffraction is the phenomenon in which light bends across the corner of a hole. Okay, now we have to understand diffraction due to a single slit. Earlier, the interference pattern we studied, that was due to two slits, but today the diffraction pattern will be observed by a single slit. So let us consider a single slit here. The hole is very small. It is equivalent to the size of the wavelength of light. This is screen at a distance d. Suppose light, the slit is here. Small d is the thickness, the width of the, not thickness, width of the slit. And light bends here due to diffraction and it follows a path here and reaches point P. Okay, similarly, this is the midpoint. It should travel here at the central right, but it also deviates in similar way. But I am making this diagram. Suppose this is not D, small a, and light going from here and reaching point P. This is the path difference. Let it be AB, and theta, this angle is theta, this angle is theta, let it be n. An is the path difference. An is the path difference, and the value of An will be A sin theta. Here An will be A sin theta. A sin theta. This is the path difference. Now one thing is very important. In the diffraction pattern, the condition for maxima and minimum is just opposite to the condition of the interference pattern. For maxima in interference, the path difference was n lambda, but in minima case, the path difference will be here n lambda. How? Suppose the path of the path difference A sin theta is equal to lambda. Here, one thing for illustration, suppose there are 100 points between A and B. Actually, each point, the wave front passing through this slit, this wave front that passes through this portion that is of width A, this is the wave front, and according to Huygens principle, each point on the wave front behaves like a new disturbance. Let, for example, let 100 points are here. So, and 100 points are making the path difference due to this 100 is, for example, suppose the path difference due to this 100 waves at this point is lambda due to 100 source of disturbance. This is the 100 source of disturbance from 1 to 100, and the path difference due to this hole from here to here, this width, that is lambda. So from half of the width, that is from 1 to 51, from 1 to 51, the path difference will be lambda by 2. From 2 to 52, the path difference will be lambda by 2. From 3 to 53, the path difference will be lambda by 2. And again similarly, from 50 to 100, the path difference will be again lambda by 2. Okay? What happens? This the phase due to disturbance originated from 2. There are 100 source of disturbance. The source of disturbance due to 2, the source of disturbance due to 52. They cancel each other because path difference is lambda by 2. Opposite. How opposite? Here we can understand, since phi is equal to 2 pi by lambda into delta x, if path difference is lambda by 2, then phase difference will be pi. 180 means opposite to each other, so they cancel. This one, the wave of this cancels the, due to opposite phases of both, cancel each other. Due to this, both cancel each other. Therefore, the only path difference at point P is observed, that is lambda. Okay, but one thing is very important to understand. This is the, from here to here, from central to here. This is the, from central to here. This is the illuminated zone, bright zone. This is the first dark. From here to here, this is the first dark. Similarly in opposite direction, means where the bright zone get finished, the first dark started. So first dark is here, means from here to here and from here to here, this will be the central maximum, width of the central maximum, this plus this width of central maximum, because this is the bright zone, this is the bright zone, this whole is the central maximum, width of the central maximum. This is the first dark here, this is the first dark starts here. I will calculate the width of central maximum, but one thing is here, a sin theta is equal to lambda. This is the first minimum, because first dark starts from here. Therefore, I have written a sin theta is equal to lambda. For second minimum, a sin theta will be 2 lambda. For third, a sin theta is equal to 3 lambda, and so on. Therefore, I am saying that in diffraction pointer, the power difference will be, the condition for the maxima and minima will be opposite. For maxima, it was a sin theta is equal to L lambda in interference pattern, but here for minima a sin theta is equal to lambda. Okay, L lambda for nth dark. For first dark, this is lambda. For nth dark, this will be L lambda. Similarly, the nth bright, that will be 2n plus 1 lambda by 2. This will be the condition here. For nth, this is for nth bright, this is for nth dark. So now we have to calculate here, but before that, it is very necessary to calculate the width of central maxima. So let us find this value. This angle, for the sake of convenience, we can calculate here. This is theta also. This is theta also, because theta is very small and small d is very small. Small d is very, very small than capital D. Therefore, we can take approximation here. This angle will be theta and this angle will be theta also. Suppose nth, we want to find the center width of central maximum. For that, let it be y. Here y is equal to, can be calculated from this tan theta, from this triangle. Tan theta is equal to this y by d, and also a sin theta is equal to, if n is equal to 1, then 1 into lambda, that is lambda. This is for first dark from here to here. Therefore, sin theta will be equal to lambda by a. And theta, for theta very small, when theta is very small, very, very small, very small, then sin theta and tan theta both will be equal. So, y by d, that will be equal to lambda by a. From here, we can calculate y is equal to d lambda by small a. D lambda by small a from central bright to one side. For total width of central maximum, this will be twice, y this and y this. So total width of central maximum, total width of central maximum will be 2d lambda by A. This is very important here. This is the difference here in diffraction pattern, that the total width of central maximum will be 2 into d lambda by small a. And now other bright fringes, the width of bright fringes from here, the next bright fringes, the width of the next bright fringes, that will be d lambda by small a only. But the width of the central maxima will be 2 d lambda by small a. In interference pattern, each width, the width of each bright and dark fringes was equal. But here, the width of central maxima is 2 times d lambda by A. And other width of maximum, or you can say width of fringes, bright fringes, in every cases, or width of dark fringes in every cases will be same, that will be d lambda by small a. But only in this case, the width of central maxima will be double. Okay. Now, okay. So this is all about the diffraction due to a single slit, width of the central maximum. I think if you repeat it 2 times, 3 times, then you can get the concept. So now the class is over now, and one thing I would like to suggest: practice, practice and do practice.